Hi guys and welcome back. Today we are going to learn about image segmentation and object detection using Detectron2, which is a very famous library used for object detection and image segmentation developed by Facebook. We're going to start with an introduction to image segmentation and Detectron2. After that we are going to do some hands-on practice with simple inferencing using Detectron2 models. So first we're going to start with importing our libraries and dependencies. Then we're going to load some data from the pre-trained COCO dataset and use the Detectron2 to get all the inferencing and results. Then we're going to display our images and our result outputs. At the end we will discuss some conclusions and look at the different things we can do with this library. Alright, so let's get started to our coding part, and here we go. For this purpose, this is an official tutorial launched by Facebook, and you'll have to download all of these libraries on your own. First one, you have to install the YAML 5.1 version, because this is important to run the Detectron2. Next we're going to use Torch, and Torch is the basics of Python when you're dealing with deep learning libraries. We're going to install a special version of CUDA, which is the library that enables GPU monitoring, meaning this gives us the access to GPUs and computation power of Google Colab. So we're going to go ahead and start with installing all of these libraries, and as you see I've already done this in order to save us some time. Different dependencies, different libraries and environment is setting. Right. So now we're going to import the Detectron2 model, which is developed by Facebook, as I mentioned earlier, and then we're going to set up the logger. We're going to import NumPy, JSON, and you're going to import CV2ImShow. CV2ImShow helps us display images, whereas the model zoo in Detectron2 is composed of a lot of different trained models. These models are able to perform image segmentation or object detection. So we are going to run this cell as well, and it's going to take a few seconds. Now we're going to get our image. We get this image from a URL, and it is a JPG image. We name it as input image, and it gets stored in our local directory. So let's do that, and we have CV2ImShow image, right? And we display the output. We get this image here. So it's a simple image with a man on a horse. There's people standing beside him. It's a whole scene. After that we are going to get some models from the model zoo. Now, as I mentioned, model zoo is the built-in pack of models that COCO segmentation does, and we are going to give it some path and a YAML. Now YAML is a file that keeps track of all the dependencies, that keeps all the class of the model, the structure of the class, all the variables and everything in it. So we get this from a link that we are just using it here. I have copied it, and you can store it in cfg.model. We get the head threshold score set to 0.5, meaning you only return objects that have more than 50% of the probability. After that we get the weights. Again, we use the same path for this. It's a URL checkpoint. The model gets to this point, and it just downloads these weights in it, and we get the output here from the model. Right, so if you want to just display the output, you can go ahead and print it out. it's going to have a lot of information in it. So it's going to tell us about the instances it has found in the image. So it is 15, the image height, image width, and the prediction boxes. Now prediction boxes are the boxes that are drawn outside an object, and these they have x, y, height and width parameters with it, right? And all these boxes are followed by their corresponding probabilities, meaning this box, the first box, which is 126 point, and it starts from here and ends at 480.00, has a 0.99% probability that it is a class 17 object, right? So we get boxes, we get their corresponding scores, and we also get their corresponding classes. So that is how you can get different information out of these output images, out of these output models. Next, we are going to have a look at the, we are going to print the instances, and you just go print and outputs. Since this is a dictionary, we are going to use the instances keyword, right? And we're going to use dot predict class, right? So this is how we can get the classes from this outputs. Alright, so it must be small I, right? And we have predict classes, and there's an extra s here, we get that removed. So here we go, we have all the different classes that we can get. So there's 17, 0, 0, 0. Now 0 must be a background, whereas 17 could be a horse. 25 will represent a person, since there's 3. So this model has detected at least 3 people in this image, right? So that is how we get the classes of our model. Now we can also use outputs and do instances dot predicted boxes. This will give us the dimensions of the boxes that the corresponding objects lie in, right? So that is how we do the object detection and segmentation, image segmentation with this bit. For visualization, we use the library called visualizer. It's a pre-built library. You just have to pass it the image as it is, and you can specify the dimensions followed by a -1, meaning keep the image as it is without any changes, right? And then you give it some parameters, metadata catalog dot get, and you can do cfg dot datasets, right? And datasets dot train. So we have all of these variables set to different values, and you just at the end we use scale equal 1.2 to set the scale of the image, and we can just run this line to check, yeah, it works. Alright, so now we have output equals v dot draw instances, right? We draw the instance predictions, and we pass it the outputs, and you can do instance, we get the all of the instance key from the dictionary and pass it to our device, that is CPU. Now this is important because since we converted all of our data into CUDA, into tensors, that is for the library to understand, we have to convert it back to CPU in order to display, right? And then we have CV2 IAM_show, and we get out dot get image, right? We get the image, and you again pass all the parameters that are necessary to define its dimensions. And here we go. Let's run this part. And alright, so it has a capital I instances, or it has S here. So we run this part of the code, and there you go. You have image segmentation as well as bounded boxes around these objects, right? So this Detectron2 is a very helpful library. You can perform different tasks based on segmentation as well as object detection. For another important feature of this library, we need to move on to the another model, right? That is called the panoptic model, and it has further functionalities that can be used, but you get the basics of it, and that is how you can use Detectron2 in your projects. You can use it for object detection. It's simple. It's like very few lines of code. There is no technical knowledge that you have to go through in order to run this library. It's very straightforward, just like I have done it here, and you can get your outputs from it along with the probability of class detections. Like I told you, we can perform all the segmentation and object detection problems with this simple library. It's lightweight, it can be imported to different platforms, it works across different platforms. Now this is for image segmentation. Image segmentation can be instance segmentation or pixel-wise segmentation. Pixel-wise segmentation is basic classification down to the level of pixels, where you have to assign each and every pixel of the image to a separate class, right, or to some class, and at the end you combine all these pixels and assign it one color, and we get segments of objects in our image. So you can use that. You can use this visualizer to draw your outputs on your images. It can be boxes, it can be different colors. In order to explore more about this, you need to head to Detectron2 library documentation, which is provided in the link below. If you want to learn more about AI, data science, and machine learning, please head over to our channel AI Sciences, and do support us by liking, subscribing, and sharing our videos. Alright, see you in the next video.